Linear algebra is anchored on the concepts of linear equations. Hence, before we go to any other complicated structure, let us first go to the basic structure fundamental to linear algebra, which are the linear equations and its systems. So, we're going to learn the following. We are going to see what are the different linear equations in n variables, what are the different solutions and solution sets of a specific linear equation. Then, we're going to go to systems of linear equations, as we can have more than one linear equation to solve at the same time. And how do we solve and find the solution for a system of linear equations? So first, let us define a linear equation in n variables. A linear equation in n variables, x sub 1, x sub 2, x sub 3, up until x sub n has the form a sub 1 x sub 1 plus a sub 2 x sub 2 plus a sub 3 x sub 3 plus until a sub n x sub n equals b. The coefficients a sub 1, a sub 2, a sub 3 up until a sub n are real numbers, and the constant term b is also a real number. The number a sub 1 is the leading coefficient, and x sub 1 here is the leading variable. Alright, so n variables can mean in one variable, two variables, three variables, and so on. So, for example, we have a linear equation in two variables. That means I can have an equation such as x sub 1 plus x sub 2 equals 3, where my coefficients would be 1, that would be my a sub 1 here, and 1 rather, that is my a sub 2. So we are just defining what a linear equation might be. Usually, when we were back in high school, we have linear equations usually of the form x plus y equals 2, x plus y equals 3. They are actually somewhat similar, it's just that there's a different use of variables. So I can quickly replace x and y here with my variables x sub 1 and x sub 2. So I can have this as this similar equation here, x sub 1 plus x sub 2 equals 3. Anyway, these are variables. Take note that the coefficients are the ones, these numbers here. So I can also have another equation such as 3x plus 2y equals 10. So my a sub 1 will be 3 and a sub 2 will be 2. That depends on the equation that we're dealing. So we just have to take note that we're not just dealing anymore with simple equations such as x plus 2 equals 5, but we're now dealing with more complicated equations. And we can also have an equation as long as this. Let's just go down a little bit for more space. There you go. We can have an equation as long as 2x sub 1 plus 3x sub 2 plus 4x sub 3 plus 5x sub 5 plus 6x sub 6 equals 0. And we're going to deal with these kinds of equations. Not just one, but there might be more than one of these equations. But before we go further, we have to identify which are linear equations and which are not linear equations. Take note that linear equations should be of this form. Oops, there you go. That means when you look at the exponents, there should just be 1 as the exponent. If we will encounter something like x squared plus 4 equals 0, this is already not linear. Or if we will encounter equations such as sine x equals 1, this is also not linear. So we have to make sure that our variable x, or it can be y, but usually it's variable x, should only have 1 as the exponent, and that is the only variable there. It cannot be, x cannot be an exponent itself, just like 2 raised to x. This is also not linear. So let's see, we have to identify which equations are linear and non-linear. So we have here 6 equations and we have to determine which of the following are linear and nonlinear. Again, for our equation to be linear, we have to make sure that it will have the form a sub 1 x sub 1 plus a sub 2 x sub 2 plus until a sub 3 x sub 3 plus there equals b. So we have our numerical sorry, wait a moment. There you go, numerical coefficient. Then we have our variable here. That should only be x sub 1 or x or any other variable possible. Alright, so pause the video and try to see which of the 6 is linear and nonlinear, which rather is nonlinear. Alright, so we have the first one, 3x plus 2y equals 7. So let us see. If we would have here, following our format here, we have 3x plus 2y equals 7. Their exponents is obviously 1. So we don't have much of a problem there. It follows our format. Therefore, this is a linear equation. The second one, exponents are all just 1. And even though we have 1/2 here, this is still a real number. This is still an element of the set of real numbers. Pi is also still an element of the set of real numbers. So therefore, this is also a linear equation. Take note as well that the constant b is still an element of the set of real numbers. In the third one, even though we see a sign, it says sine pi. And sine pi, this is actually a constant because it's sine of a specific real number already. So this is okay. And of course, we still have 1 as our exponents. E squared, this is still an element of the set of real numbers because e is an irrational number but still a real number. Hence, this is still a linear equation. Now, however, these other equations are not. The first one here is already x times y, which gives that a power of 2 actually. This is actually the exponent of that specific term. Hence, with that already, this is not a linear equation. The second one, x here, our variable is an exponent, which is not allowed in our definition. So this is also not a linear equation. The third one also has the sign, but as you can see, what we got is the sign function of the variable, not of a specific real number. Hence, this is also not a linear equation. So that's how we define our linear equations, and we're going to learn more about them in the next video.